Today's lesson is over angle measures. So our I can statement for today is I can name an angle and its part. So let's go ahead and get started. This is an extremely important concept because we're going to be naming angles all year long. And it's really important that we learn how to do that now. So first definition we have here is a ray. So a ray is a line. It's a part of a line. And it's got one endpoint and extends infinitely in one direction. So go ahead and write that into your notes there. One endpoint extends infinitely in all directions. And one of the most important parts here that we will need today is we will always name rays with their endpoint first. Okay, always name rays with their endpoints first. So let me show you what I mean. If we had, let's say, this ray right here, let's say this was J, K, okay? We will always want to name it with the endpoint. So do you guys see how this right here is a point? This right here is a line. So we will always want to start this off with the endpoint. And we will put a line over top of it, but we only will have one arrow on that line, okay? So that is a ray. Make sure we understand how we can use that and how we name it. Next up, opposite rays. Opposite rays are two rays that share an endpoint and form a straight line. So that right there is very important. They form a straight line. So what that looks like here is if we had a ray that went this way, right? And let's see, let's call this ST. And we also had a ray that went this way. And we can call this SU, right? Then we're going to have this line right here. And this is going to be, I know mine doesn't look very good, but this is actually a straight line, okay? So this is a straight line. And the reason this is so important is because every time we see a straight line, we are going to need to know what amount of degrees are in that straight line. How many degrees are in this straight line? So please write this in your notes as well. Anytime we have a straight line, it is going to be 180 degrees. Okay, so anytime we have opposite rays that form a straight line, that is 180 degrees. This is extremely important for us to know. So please put that in your notes. Maybe highlighted it, put some, put some stars next to it. Do whatever you got to do. Make sure you know that. Key concept here, an angle. Okay, now we're going to name an angle. Angle, again, go ahead and write this definition in, is formed by two non-collinear rays that have a common endpoint. So two non-collinear rays that have a common endpoint. So one of the biggest things for angles is the vertex. Okay, I know you guys have heard of the word vertex before. So the vertex is whatever point that the angle is in. So notice we have B, we've got A, we have C. The angle here lies right here at vertex A. Okay, so the reason that this is so important, one reason is because we can actually name this angle A if we wanted to. So there are going to be some times where we can use one letter angles. Sometimes we're going to have to use 3 letters. Okay, that's going to be something that you guys are going to have to get used to again this year. So make sure you know this as well. So here, B, A, and C are our 3 points. The reason it is so important to know the vertex is because no matter how we name this, if we use 3 letters, the vertex has to be in the middle. Has to be in the middle. Okay, so let's look at these examples here. Angle BAC, angle CAB. All right, both of those have the A in the middle. As long as your vertex is in the middle, the other two don't really matter. They could go either way. As long as we have that vertex in the middle, that is the most important part. So please, again, this is extremely important as well. Star this, highlight it, whatever you got to do. This is extremely important. Now notice they also name this angle 4. So this isn't going to be an option that we have often, But as you can see, there is a 4 right here in this angle. So you can also name the angle by whatever number is on the inside of the angle. So for example, if we had this right here, and I said this was a 2, then you could call this angle 2. All right. Notice all of these angles right here before our letters. That's important as well. We can't just say 4 or A or BAC. We have to put that angle symbol in front of it. Next up here, let's do some practice on naming some angles here. So this one says, number 1, name all angles that have B as a vertex. Okay, B as a vertex. So looks like B is right here. So what I'm going to want to do is I'm going to want to look at all of these angles where B is the vertex. And I'm going to go ahead and start naming those angles by letters. I'm going to use 3 letters here. So first one I see is this top one. I'm going to shade it in here for you guys. Right there. I'm going to erase it now so we can see B. So I'm going to call this one. I know I need G and I need B and I need A. B is the vertex. So as long as I have B as the vertex, we should be fine. So GB and A, angle GBA. That is what I would call this angle right here, this top angle. Over here, this angle to the right. So this is, we could name this angle 7, but again, I want to name this by the angle with the letters. So I'm going to say angle ABD. Angle ABD. Right here, I want to name angle 6 right now. I want to name angle 6. So again, B is our vertex. B's got to be in the middle. So let's name this angle EBD. Okay, EBD. That would be this little area right here. Lastly here, I want to hit angle 5. So again, B is our vertex, which means B's got to be in the middle. So let's go ahead and say EBG, angle EBG. Okay, so forgot to highlight this right here, but hopefully you guys can see where I'm getting those angles from. Hopefully you understand that the B is in the middle for every single one of these, and that's because that is the vertex. So when we're naming these angles, the vertex has to be the middle letter. The other 2 letters can be flip-flopped if they need to. Okay, so go ahead. I want you guys to try to work on questions number 2 and 3. Go ahead and give this a pause, and once you return, I will complete these number 2 and number 3. Okay, number 2 says, name the side of angle 7. So the sides of angle 7. Well, angle 7 is right here. And if we want to name the side here, I notice these are rays, right? So B is our vertex, and these lines here are going to extend forever and ever. So these are going to be our 2 sides here, and we got to remember, back up to the top here, how do we name a ray? We got to make sure that our endpoint is first. Okay, the endpoint is first. So this is going to be angle. I'm sorry, not angle. This will be ray, BA, and ray, BD. Make sure our arrow is extending forever in one direction and not both directions. So that would be our answer for this one. Number 3, what is another name for angle 5? So we've actually already named this before. We can name this here angle EBG, or we can name this angle GBE. Okay, either one of those would have worked. Okay, let's check out the backside here now. So again, this is something you guys have probably learned before. but it is important that we hit it again. So first things first here, a right angle. I know that we've already talked about it this year, but a right angle is 90 degrees, and we have this little box right here. This little box, anytime you see it, it means that it's 90 degrees, okay? If the box is not there, we cannot assume that is 90 degrees. That box, that symbol, has to be there, okay? An acute angle. Okay, acute angle is less than 90. Less than 90. So it will always look smaller than a 90-degree angle. Okay. Lastly, here we've got the obtuse angle, which is clearly greater than 90. So you will know just by looking at a lot of these angles whether or not we have a right angle, an acute angle, or an obtuse angle. So again, obtuse greater than 90, less than 180. Okay, let's go ahead and try to do these questions here. So it says use the figure to the right to classify the angles below. Number one, we want to classify VYX. So I'm actually going to outline that. VYX. So it looks like to me that is where this right angle is coming in. So we are going to say that this is a right angle. Okay. So since there's a box there, there's that symbol, we know that that's a right angle. Question 2, TYV. So TYV. Okay. Now, I want you guys to pay close attention to this one. So, in the previous question, we said, hey, this is a right angle, right? And we know from the last page that opposite rays form a straight line. So I want you to look at the ray YX, and I want you to look at the ray YT. Okay, I'm going to erase this for now. Do you guys see how these are opposite rays? These guys go in both directions. Y is the common point, and they go forever and ever in opposite directions. So that's going to form a straight line, right? So we are going to have a straight line here. And when we have a straight line, the question is how many degrees is a straight line? So hopefully you told yourself 180 degrees. So if this whole thing here is 180 degrees, and we know that this right here from our previous question is 90, then that means this other side over here is going to be 180 minus 90, which means that this also has to be 90. Okay, so this would also have to be 90, which is a right angle. And that is because we are given opposite rays. I know this is a little mess here. We're given opposite rays between YX and YT, which form a straight line, which is 180 degrees. And since this side, we already said was 90 degrees, this side over here also has to add up to 90 degrees. Okay, so the reason that we're able to say that this is 90 degrees is because this forms a straight line, this side's 90 degrees, which means the other side has to be 90 degrees. Okay, that's going to be that one of those few instances where we can say, even if it doesn't have a box, we know that it's 90 degrees. Okay, so let's go ahead, do this final one, number 3 here. Angle 3, we got TYU. So TYU. Hopefully you guys can see here how this is much less than 90 degrees, which would mean this is an acute angle. All right. Last part here. Again, another big thing. So we've already talked about a segment bisector this year, and a segment bisector is when we have a segment that cuts another segment completely in half, right? So we actually are now going to have something called an angle bisector. And an angle bisector does the same thing, except for it does it to an angle. So much like a segment bisector cuts a segment in half, an angle bisector cuts an angle in half. Okay? An angle bisector cuts an angle in half. So, for example, if this full angle ABC was 40 degrees, if ABC was equal to 40 degrees, and you told me that BD bisects angle ABC, well, that means that our two angles ABD, and angle DBC would be equal to both 20 degrees. Okay, so since this is an angle bisector, it cuts the angle completely in half to where both of these are exactly the same. All right, so let's do some practice on this. I'll do number 4 with you guys, and then I want you to do number 5 on your own. It says in the figure, BA and BC are opposite rays, which I will give you guys a clue here. That means this is 180 degrees. BF bisects CBE. BF bisects CBE. Okay, if we have something like this, the first thing I want to do is I know since this is a bisector, this angle 3 is going to be equal to this angle 4. So what we're going to do here is we're going to put these little loops on our angle. Okay, anytime we have that, and this is important, anytime we have that, that means that these angles are what we call congruent or equal. Okay, so these angles are congruent, which means they are equal to each other, angle 3 and angle 4, and that's because this angle bisector cuts this full angle in half to where both of these are equal to each other. Okay, now it says if the measure of angle EBF is 6x plus 4, okay, and we said that CBF was 7x minus 2, they want us to find the measure of EBF. Okay, now, in order to do this, notice we have already made these looping marks on our angles that tells us, hey, these are going to be congruent. So all we need to do is, since our angles are equal to each other, we are going to set our algebras equal to each other. Okay, so when angles are equal, when the angles are equal, the algebras are equal. When the angles are equal, the algebras are equal. So here we know that angle EBF is equal to angle CBF. So we are going to say that angle EBF, or 6x plus 4, is equal to 7x minus 2. Okay, so that is extremely important, something you guys are going to do many more times this school year. Is you're going to set the algebras of congruent angles equal to each other. So if we solve this here, I'm just going to go through this quickly. This is going to be 4 is equal to x minus 2. Add a 2 to both sides here, and we're going to get x equals 6. Now that's not the final answer here because they want the measure of angle EBF. So the measure of angle EBF is going to be equal to 6 times x. This is where I'm getting this from. 6 times x plus 4, we said that x was 6. So I'll draw a little arrow for you if you got lost along the way. This is where our 6 is coming from. So the measure of angle EBF is going to equal 40. Okay, it's going to equal 40. So go ahead, do number 5 real quick. This is the last thing we have for this lesson today. Give yourself, go ahead and pause this. When you return, I will be completing our final one here, number 5. All right, so it says in the figure BA and BC are opposite rays. BF bisects angle CBE. So BF bisects angle CBE. They're saying here, if the measure of angle 3, well, first of all, before we do that, we know that these are equal to each other, right? So since this is the bisector, it cuts it in half, which tells me this is equal to this. So angle 3 is going to be equal to angle 4. Angle 3, they say 4x plus 10. And angle 4, I'm sorry, not angle 4. The measure of angle EBC. The full thing is 9x plus 10. Find the measure of angle 4. Okay, so this is a little bit different. So we're not going to use the same exact process. I wanted to see if you guys would be able to figure this out. What we're going to do here is, if we know that we've got this whole angle EBC, and we have 2 angles that are equal to each other in this as well, I know that angle 3 and angle 4, if we added those together, that would give us this full angle of angle EBC, right? That would give us the whole thing. So what I want to do here, since these are equal to each other, and we know that this is 4x plus 10, and we know that the full angle is equal to 9x plus 10, what I want to do is make angle 4 the same as angle 3. I want to make angle 4 the same as angle 3. So angle 3 is 4x plus 10. Well, guess what? Angle 4 is equal to it. So angle 4 is also going to be equal to 4x plus 10. So we're going to substitute these in for angle 3, angle 4. We're going to substitute 9x plus 10 in for angle EBC. We're going to be on our way here. And this is going to be the last example. So 4x plus 10 plus 4x plus 10 is equal to 9x plus 10. Again, combine like terms here. So we're going to take our 4x's together, and we'll also take our 10's together here. So combine your like terms here. Combining our reds, we're going to get 8x. Combining our greens, we're going to get 20. So 8x plus 10 is equal to 9x, or sorry, 8x plus 20 is equal to 9x plus 10. Go ahead and subtract that little brother. Always subtract the smaller variable. X plus 10 is equal to 20. Subtract a 10 from both sides here. We're going to get x equals 10. Okay. Lastly, in order to solve for the measure of angle 4, just plug that back in. So measure of angle 4 is 4 times x plus 10. Well, we said that x was 10. So we're going to plug in our 10 for x. And we're going to get measure of angle 4 is equal to 40 plus 10, which would give us 50 degrees. Okay. Hope this helps. Let me know if you guys have any questions.